In this video, we'll talk about greatest common factor, GCF, and factor by grouping. And we'll do that for polynomials. So let's review first what greatest common factor means and how it's done for numbers so that we can apply it to polynomials. So how to find greatest common factor? That's why we have GCF, right? Greatest common factor. Well, we want to factor completely or do the prime factorization when we deal with numbers, and then multiply common factors to the lowest power. So you see how it's called greatest common factor, and we are actually looking for the lowest power. So let's do this example, greatest common factor of 90 and 300. So let's do the prime factorization for 90. So 90 can be divided by 2 and we get 45, then by 3 and we get 15, and then by 3 again and we get 5. So basically 90 can be written as 2 times 3 to the second times 5. These are the factors of 90. And let's do 300 now. 300 divided by 2, it's 150, divided by 2, it's 75, divided by 3 is 25, and 25 divided by 5, it's 5. So the prime factorization is, for 300, is 2 to the second, right? We have 2 to the second, and then times 3, and then times 5 to the second. So based on the process of getting the greatest common factor, between 2 and 2 to the second, we're going to copy 2. Between 3 to the second and 3, we're going to copy 3. And between 5 and 5 to the second, we're going to copy 5. So when we multiply 6 times 5, 30. 30 is the greatest common factor. What does that mean? If we divide 90 by 30, we get a whole number, 3. If we divide 300 by 30, we get a whole number, 10. And 30 is the greatest common factor because 2 is a common factor of 90 and 300. 3, it's also. 6, it's also. 15, it's also a greatest common factor, but out of all those factors, the greatest one, it's 30. Let's do greatest common factor of 2x to the third y and 3xy to the fourth. So between the numbers 2 and 3, the greatest common factor is 1. So we can write it or not. Between x to the third and x is x to the lowest exponent, which is to the first, right? And between y to the first and y to the fourth, the greatest common factor is just y. So the greatest common factor of 2x to the third y and 3xy to the fourth, it's xy. This factor is dividing each of these expressions evenly. All right, so now let's do a few examples for polynomials. So let's take a look at example 3. 2x squared plus 4x, and we want to factor out greatest common factor. So the greatest common factor of 2x squared and 4x, it's 2x. So we get 2x times, and what is left when we factor out 2x, it's x plus 2. Or if you want, we can say 2x squared can be written 2 times x, and 4x can be written 2 times 2 times x. So if you notice, 2x, it's common here and it's common here. So if I factor it out, what is left, it's an x plus 2, so that's what remains inside the parentheses. Let's take a look at example 4. So a common factor in example 4 is 3x. And what is left? 7x plus, oh, sorry, it's not 3x because I have 21 and 28. Both of them can be divided by 7, sorry, not by 3. So 7x times 7 times what gives us 21? 3. So 3x plus 4. Now it's correct. And then example 5, 9x to the 5th and 15x to the 3rd, 3x to the 3rd, it's a common factor, and we have left 3x to the 2nd plus 5. Now let's take a look at example 6 really quick. We have 16 and 24, so the common factor is 8. Then we have x to the 2nd and x to the 3rd, so x to the 2nd, it's a common factor, and y to the 3rd and y to the 4th, y to the 3rd, we copy the lowest one. What is left when we factor that out? It's a 2 minus 3xy. And let's solve 8 star. 8 star looks like 8, and be very careful. If the leading term starts with a negative, we have to factor out the negative. So basically, between 4, 8, and 16, a common factor is 4, but because the leading coefficient is -4, we factor out -4. So then when we factor -4 out, we get x to the 2nd plus 2x minus 4, right? Because if we factor out this negative, the other signs change, right? -8 divided by -4 is 2. So that's why we have +2. Positive 16 divided by -4 is -4. So that's how we got that. And we factored the greatest common factor. Now let's take a look at factoring by grouping. So if we look at the example 9, we have 2 times x minus 7 plus 9a x minus 7. So we notice that x minus 7, it's a common factor. So we'll factor that out, x minus 7. And what is left when we factor x minus 7? 2 plus 9a. So that goes 2 plus 9a inside the parentheses. So now we have 2 factors. Let's take a look at example 10. So here, 5y times a minus b minus a minus b. So a minus b, it's a common factor. We factor it out. And what is left is 5y minus, well, in front of this parentheses, even if we don't have it, it's actually -1. So we end up with 5y minus 1. And let's take a look at example 11. Well, example 11 is different than 9 and 10, but I notice that I have x to the 3rd minus 5x to the 2nd plus 3x minus 15. So if we look at this, we don't have a common factor between, or like a greatest common factor between all terms, right? There is nothing in common between all, but we can group them. So we group the first 2 terms and the last 2 terms. Most of the time it works when we group the first 2 and last 2, but sometimes it works if you group the first one with the 3rd one and the second one with the 4th one or something like that. Anyway, between the first 2, x to the 3rd minus 5x squared, we factor x squared out and we are left with x minus 5. Then between the last 2 plus 3x minus 15, we factor plus 3 out. And I notice that many students forget to put the plus and they just times it there. It looks weird, but let's put plus 3 and x minus 5 is left. So now x minus 5, it's common. So we do x minus 5 times x squared plus 3, which is left. And now it's in factored form. And let's take a look at the last one. We see x minus 2 here and 2 minus x. Well, what is the difference between them? So x minus 2 versus 2 minus x. Well, if I factor out negative, or let's say this one, 2 minus x is negative x plus 2 is the same thing. If we factor out -1, we get x minus 2, or negative x minus 2 written like this. So in other words, and 2 minus x, so 2 minus x, it's the same thing as the opposite of x minus 2, right? Negative x minus 2. So what I mean by that is that when I want to solve example 12, so 3 times x minus 2, I'm going to rewrite 2 minus x as negative a times x minus 2. So I replaced exactly what we just proved here, that 2 minus x is negative the quantity x minus 2. So now x minus 2 is a common factor, and we are left with 3 minus a, and we factor it completely.